Have you ever really looked at a QR code? Not just glanced at it but actually stopped to notice the details? You see them everywhere, on menus at your favorite cafe, on posters advertising concerts, and even on the packaging of things you buy at the store. They've become a part of our daily lives, quietly connecting the physical world to the digital one. But if you look closely at any QR code, you'll notice something curious in the corners. 3 big, bold squares. They're always in the top left, top right, and bottom left. The bottom right? It's left empty, almost as if it's missing a piece of the puzzle. Why 3, not 4? It's not a mistake or a design flaw. In fact, it's a deliberate choice that holds the secret to how QR codes work so reliably. Those 3 squares are the secret key to how QR codes work. They're called finder patterns, and they're essential for the magic to happen. When you point your phone's camera at a QR code, these squares are the very first thing it looks for. They act as anchors, helping your device quickly spot the code in a sea of black and white dots, no matter the angle or lighting. Without these 3 squares, your phone wouldn't know where the code begins, or ends, or even if it's upside down or sideways. Scanning would be a frustrating guessing game. Think of these squares as the North Star for your phone's camera, providing a fixed point of reference so it can instantly orient itself and decode the information. They're the silent heroes, working behind the scenes every single time you scan a code, making the process seamless and almost magical. So next time you scan a QR code, take a moment to appreciate those 3 corner squares. They're doing the heavy lifting, making sure everything works smoothly. It's a fantastic question. Why are they there? And why only 3? The answer is more interesting than you might expect. The answer is a story of smart engineering and clever problem solving. A tale of how a simple idea can solve a complex problem. With just a few simple shapes, QR codes unlock a world of information, connecting you instantly to websites, apps, and more. Let's dive in and explore the science and design behind these 3 mysterious squares and see how they make QR codes so powerful. This journey will take us from simple shapes and patterns to the cutting edge of modern technology, revealing the hidden genius in everyday things. Consider this your invitation to become a QR code expert. By the end, you'll never look at those little squares the same way again. Ready to see what's really behind those little black and white squares? Let's get started and uncover the secrets together. The story is more fascinating than you might think, and it all begins with those 3 big squares. So, what is a QR code? You've probably seen these little black and white squares everywhere, but have you ever wondered what they actually do or how they work? Let's break it down. QR stands for Quick Response, and that's exactly what it delivers. It's designed to be scanned and read instantly, making it super convenient for both businesses and everyday people. Think of it as a super-powered barcode, those lines on grocery products but way more advanced. While a traditional barcode can only hold a small amount of information, a QR code can store so much more. A QR code stores data both horizontally and vertically, using a grid of black and white squares. This unique design is what allows it to pack in so much information in such a tiny space. That's why it can hold thousands of times more information than a regular barcode. It's like upgrading from a post-it note to a whole notebook. You see them everywhere because they're incredibly versatile. They can be printed, displayed on screens, or even worn on clothing. Scan one at a restaurant for the menu, and you'll instantly see what's available to order. No need to touch a physical menu. On a ticket, it proves it's real, and lets you enter events quickly, without waiting in long lines. Or in a museum, scanning a code next to an exhibit can reveal videos, audio guides, or extra facts right on your phone. They can take you to a website, connect you to Wi-Fi in a cafe with a single scan, or even download an app instantly, or let you pay for coffee, all with a scan. No cash, no cards, just your phone. Each tiny square is a bit of data, like a 1 or 0 in computer language. Together, they form a digital puzzle that only your phone can solve. Your phone's camera snaps a picture, and an app deciphers the pattern. It's fast, accurate, and works in seconds. It's like reading a secret message. Your phone is the decoder ring, unlocking whatever information is hidden inside. The software analyzes the grid, figures out the meaning, and performs the action instantly. It could open a website, show a coupon, or start a download. For us, it's simple, just point and scan. No typing, no searching, just instant results. But behind the scenes, it's clever technology. QR codes use error correction, so even if part of the code is damaged, it can still be read. The QR code is a bridge, connecting physical objects to the digital world. It's a shortcut from the real world to the internet. It turns a piece of paper into a gateway to endless information, making everyday objects interactive and smart. Instead of typing a long web address, you just scan. It saves time, reduces mistakes, and makes life easier. That's the power of quick response, instant access, right at your fingertips. With just a scan, the world opens up to you. Let's get back to those 3 big squares called finder patterns. They're not decoration, they help the scanner find and orient the code. Each is a square within a square, in a unique black and white ratio. This pattern is rare in other images, so your phone instantly knows it's looking at a QR code. The scanner locks onto them, using them as bullseyes to isolate the code. With these 3 points, the software figures out the code's orientation, straight, tilted, or upside down. That's why you can scan a QR code from almost any angle. The finder patterns also help determine the code's size and perspective. Are you close or far? The distance between the squares tells the software how big the grid is. Without these guides, the scanner would be lost. These 3 squares are the true heroes that make quick response possible. If finder patterns are so important, why not put one in every corner? It seems logical at first. After all, symmetry often makes things easier to understand. But when it comes to QR codes, adding a 4th square actually creates more problems than it solves. Here's the clever part. If you had 4 finder patterns, the code would look identical even if it was flipped upside down. This symmetry would confuse the scanner, making it impossible to tell which way is up and potentially leading to errors in reading the data. With just 3 points, the QR code forms a unique L shape. This L shape is instantly recognizable to the scanner, so it always knows the correct orientation. No matter how you rotate the code, the scanner can quickly identify which side is which. Think of it like a 3-legged stool, always stable, never wobbly. 3 points define a plane, so the code is always balanced and easy to interpret. The empty bottom right corner isn't just a blank space, it's a crucial clue. It tells the scanner, this is the bottom right, acting as a silent guide for the machine to read the code correctly. This design means there's no confusion, no ambiguity. The code can only be read one way. The scanner doesn't have to guess or check multiple orientations. If the code could be read upside down, the data would get scrambled, leading to failed scans and frustration. The 3-corner system eliminates this risk entirely. The 3 points form a non-symmetrical shape, giving the scanner all the information it needs to decode the message accurately. Sometimes, less really is more. Adding a 4th square would only create confusion, not clarity. It would make the code harder to scan and less reliable in real-world situations. By leaving one corner blank, the QR code remains robust, reliable, and foolproof, ready to be scanned quickly and accurately every time. It's a beautiful piece of geometric problem solving, where simplicity leads to strength and efficiency. That's why the system works so well, and why QR codes have become a trusted tool in our everyday lives. The middle of a QR code might look like a random jumble, but nothing is random. Every dot and line has a purpose. Beyond the 3 big squares, there are other patterns that help the scanner. Look for smaller squares. These are alignment patterns, helping with distortion on curved surfaces. They provide extra reference points so the code can be read even if it's warped. You'll also see timing patterns, alternating black and white lines that act like rulers, defining the grid. These ensure the scanner lines up perfectly with the code's rows and columns. Near the finder patterns, you'll find format information, telling the scanner about error correction and data masks. The mask breaks up large areas of the same color, preventing confusion. Every element is there for a reason. It's a masterpiece of information design, not a random mess. Here's something amazing. QR codes can work even when damaged or dirty. That's thanks to error correction, a brilliant feature built in from the start. The code has backup data woven into its pattern, using clever math called the Reed-Solomon algorithm. If part of the code is unreadable, the scanner can rebuild the missing pieces. There are 4 levels of error correction. Higher levels recover more data, but store less information. That's why you sometimes see QR codes with a logo in the middle. They're designed to survive damage. This system anticipates real-world messiness, torn paper, smudges, graffiti. Error correction keeps the code working, connecting you to information even when life gets messy. It's like a digital superhero that can heal itself. Robust, resilient, and practical, error correction is a key to the QR code's success. It's one reason QR codes are everywhere. QR codes have been around since 1994, invented in Japan for tracking car parts. For years they were a novelty. You needed a special app, and few people bothered. But in 2020, everything changed. The pandemic made touchless solutions essential. Restaurants put QR codes on tables for menus. Safe, easy, and cheap. Millions got comfortable with scanning codes. At the same time, smartphones added built-in QR scanners, no more special apps. Suddenly, scanning was seamless. The combination of need and easy tech created a QR code boom. Businesses started using them for payments, marketing, event check-ins, and more. The pandemic was the catalyst, but the technology proved so useful it stuck around. Now, QR codes are a permanent part of our digital lives. The QR code is a marvel of elegant design. It solves the problem of storing digital info on a physical object with a few clever rules. The 3 big finder patterns make scanning easy from any angle. Using 3 squares instead of 4 removes ambiguity and ensures accuracy. Timing and alignment patterns provide structure, letting the code work even when distorted. Error correction adds resilience, so the code survives real-world messiness. It's open and free. Anyone can create and use QR codes. From a simple square, you can launch a website, play music, or pay for groceries. The QR code bridges our physical and digital worlds. It's proof that the smartest solutions are often the simplest. Next time you scan a QR code, appreciate the science packed into that little square. Those 3 corner squares are a brilliant geometric solution, not just a design choice. Science isn't just in labs, it's in everyday objects like QR codes. Curiosity drives us to ask, why 3 squares? Why does it work at any angle? The missing 4th square is the key to orientation. The dots in the middle are structured data. The QR code is simple yet profoundly intelligent, designed for our imperfect world. Keep looking closer, ask questions, and notice the patterns around you. The world is full of hidden wonders. QR codes are just one example. Understanding how things work adds to the magic. That's the real cool part of science.